Okay, so again, as we notice, the life cycle of scooter engine and wheel is the same. We can indicate this on our object diagram by using a symbol which indicates aggregation. Okay, and I'll just aggregation is specified at the level where things are aggregated, and the aggregating object is the scooter. So it is using by this rhombus symbol at the end of the relationship. Okay, so this basically indicates that this is the whole thing over here, and this is the part, right? Part and part. So we have, when you have system made up of, you know, the one whole thing that aggregates the rest of the parts, this is what you use. You use these rhombuses like this, okay? These symbols represent aggregation, right? So this represents aggregation. Aggregation indicator right there. Okay, and aggregation is usually indicated by the same life cycle. A perfect example of this would be that the constructor of the scooter actually creates the engine and creates and populates the two wheels. Okay, and therefore, if some other object like this rider keeps a reference to the scooter, okay, and if you set this reference to null, okay, so you no longer have this connection. If this is a Java application, Java garbage collector will basically notice that nobody is referencing the scooter object anymore, and therefore, if it happens to be referencing other objects like engine and wheel, these will also be gone at the same time. So the garbage collector will be able to collect them all of these objects, and therefore it truly is that the life cycle of this is the same. So let's say let me see, in a C++ application you can have a stronger version of it, and that stronger version of aggregation is called composition. Okay, and in the case of composition, these diamond shapes are actually filled like this, right? In Java, a true composition is impossible because the objects are linked by references, right? If you have separate classes in Java, each instance of the class has to be created by new. And therefore, you have unique instances of these classes, and they all have to be created by new at some point or part of your application. In C++, objects can be created without new, right? So let's just very quickly demonstrate that. I mean, I can just create a very small program here. Just say file, new project right here, and demonstrate an aggregation by value. Okay, and let me see where I want to place my file. So this will be an empty project that I would like to create, and 260, and we're going to say this is an example of composition. Right, so an example of composition, and we're going to create an object. Project where we would like to demonstrate this very quickly. So in a C++ project like this, which is empty to begin with, we're just going to add a source file. We will name it main.cpp. Okay, add that, and of course just to have the demonstration. Okay, moving on. So we have Let me adjust this a little bit. All right, so we're just going to do a bit of a little piece of code here to demonstrate this. So we're going to have a main function over here, which obviously just does the standard stuff. I think I will have to pause it here, so I'll just use the pause command at the end of my main just to be able to pause it. Let me build this and run it just to see how this behaves, to test my environment. Okay, so the program runs. Right here it says press any key to continue, and then exits. Very good. All right, so here it is. This is a class named Scooter, right? And this class has two data members. One is the engine, right? One is the engine. And another one is perhaps I have a wheel class, and I'll just simply use an array of two wheels right here embedded directly in the class, right? And I will provide the constructor, which needs to be public, right? So I'm just going to say public constructor. Just resize this to be a little smaller so that I can see more code over here. So so what we have here is the constructor for the Scooter class, right? It could take parameters, but at this point I really don't have a lot to think about. And basically the constructor will populate the engine. Let me just think about my engine class engine. Okay, and the engine will have maybe the type, right? So it will have its own constructor over here, which will be specifying the type. Perhaps I have some sort of integer type over here, which I would like to initialize. Engine type, right? So we're gonna take type as parameter. Over here I will use underscore here to make it a little easier for you to see what's happening, right? And so I would like to take my type and populate it with the type provided to the constructor. Okay, and so when I construct the Scooter, I can basically construct my engine by specifying the type of engine that I want, type 0, whatever that is, right? Okay, and so this will invoke the engine constructor and its initializer list. This piece here is called initializer list for the data members. The type will be captured by the engine right here, and the engine will be constructed. So here we also use initializer list, which really I should probably use this comment right next to the column which specifies the beginning of the initializer list. And so I also would like to populate the set of wheels, but the set of wheels is placed in the array, so at this point I will use just the default constructor. So just supposedly I have class name wheel. Okay, and so right here the class name wheel will just simply be empty class. I don't care what that is, right? So but this point, if I create the Scooter, right, in C++, I don't have to use new. I can just basically populate it like this, and I have to I can create objects just like this, and this way the object is created, and basically the constructor for the scooter will invoke constructor for the engine, and then default constructor for 2 wheels, and this is specific constructor, right, which will take the type 0, and so this type will be populated. So in this case, at runtime, right, if I execute this program, which I'm showing you here, if I execute this program, what's going to be happening is that at runtime, the main program will create the scooter, right? So the scooter or object is a constructor will be invoked, right? So the object of some kind of shape and form has to be constructed in computer memory, just like this, right? And then inside it has the engine part, right? It has the engine part, okay? And it also has 2 other parts, like 2 wheels over here, right? So I'm just trying to use dotted lines because these objects don't exist just yet, but we need to create them. There are actually 2 of these, okay? So what's going to happen is that first observation is that the scooter completely contains the engine and the wheels, okay? These objects are values, the data attribute values directly inside this class. This is something that's not possible in Java, because if we write parallel example in Java, at some point we have to say new engine and new for both wheels, which take these boxes outside of the scooter class, okay? So in C++, the sequence of construction is predictable. It's always in the order of how the values are specified. So therefore, the first thing that this engine part will be constructed, and so this constructor will run first. Then the first wheel will be constructed, right? So this object will be constructed next. Then the next wheel will be constructed, and this object will be invoked next. And finally, the enclosing scooter class will be constructed. Its constructor will run, the body of this constructor will execute, and this will complete the constructor sequence, okay? So this, you can see that these parts over here, they're contained, right? They're truly contained inside the scooter, and that's what these filled diamonds demonstrate. We'd like to show it in the design diagram. If you'd like to show it and let the programmers know about this containment, you use those filled diamonds, and this is an idea is the composition. Composition equals aggregation by value, right? We say that these objects inside this the scooter are actually values, the data attributes stored directly in the scope of this box, okay? So, and that's what is done by specifying these 2 attributes right here.